In the last class, we talked about arithmetic operators, introduced the select and from clause, worked with our query designer, and answered loads of practice queries to solidify our newfound query skills. Next, let's talk about comparison operators. Comparison operators compare two expressions. The expression being compared could be from a table, column, or variables. Like the arithmetic operators we just discussed, comparison operators should be familiar to you. The comparison operators are listed on your screen. To understand the usage of comparison operators in database programming, we need to extend our knowledge about how we write queries. Up until now, when we issue a query, we have been returning or displaying all the data in the table. For example, when we wrote a query for all products sold by Northwind, we issued the query select star from products. This query returned all the products from the products table, 77 products in total. What if all we wanted to see is the product detail for a single product called Sasquatch Ale? Try saying that 5 times. We may decide to issue the above query, execute it, and look through each row line by line in the product name column for a product called Sasquatch Ale. You may be okay doing that for a table with only 77 rows. What if your table has 77 million rows? Would inspecting each row still be efficient? Absolutely not, for both 77 and 77 million rows. How about we filter the number of rows returned by our query such that we only return the exact number of rows we are interested in? For this example, we need just one row for the product named Sasquatch Ale. Whenever we need to filter the number of rows we want our queries to return in SQL, we introduce a new clause called where to the select statement. For our example, to return product data for a product named Sasquatch Ale, we write the query select star from product where product name equals Sasquatch Ale. From the above query, you will notice we have a new line starting with a new clause. The new clause is the where clause, which is used to present conditions that filter data rows to the query engine. This means whenever you are restricting the number of rows you would like your query to return, that is, you want to filter the number of rows returned, you use the where clause. For our example, we are interested in restricting the number of rows to 1, the one with the product name of Sasquatch Ale. To achieve this, we issue the where clause, signaling to the database engine that it should not return all the rows, but filter the rows based on a search condition, what we call a predicate in set theory. So, what is the search condition? To build the condition, we need to compare the product name column with the value we are looking for, which is the literal value Sasquatch Ale. This is where we need our comparison operators. In this case, we will use the equals to comparison operator to compare what is in the product name column with the literal value Sasquatch Ale. This gives us product name equal Sasquatch Ale as our condition. Every other part of the query, the select and the from clause, are interpreted same as before. Executing the above query gives us a single row of product data corresponding to the product Sasquatch Hill. For our example, we use the equals to comparison operator to build a search condition for the where clause to be able to filter unwanted rows and only present the row that fits the search condition. You can use any of the comparison operators in this way to achieve the same filter effect depending on your query requirement. Let's look at another example. You have been tasked to write a query that gives the details of NorthWind's Canadian suppliers. The data points needed are the company name, contact title, address, city, postal code, and country of NorthWind's Canadian supplier. You will see above that our query designer, which we introduced and discussed its usage in the last class, is now in version 2.0. We have added two new steps 5 and 6, to our query designer to write the query that will give us NorthWind's Canadian suppliers. Step 5 starts us off by asking if we are filtering unwanted data from our suppliers table, the output of step 4. Because we only need Canadian suppliers, the answer is yes. We will be filtering out non-Canadian supplier data from the result of our query. Immediately, this signals that we will need a where clause for filtering. In conjunction with the where clause, we need a search condition. Step 6 prompts us for the search condition. Since we are looking for Canadian suppliers, we want data values in the country column that equals the literal text Canada. This means we need a comparison operator that will allow us to compare data values in the country field that equals the literal text Canada. In the SQL command column of the query designer, you see this written out. Notice that because we are comparing the country column with a literal text Canada, we need to bound the literal text Canada in single quotes. Also, comparison operators compare columns, variables, or expression of compatible data types. Therefore, our search condition is valid because the country column is a character data type and the literal value Canada that we are comparing it to is also a character data type. Finally, in step 7, we are ready to combine the above steps to give the query that will return NorthWind's Canadian suppliers. Go ahead and execute the query to view the 2 suppliers for NorthWind that operate in Canada. You have now expanded our select statement by adding a new clause, the where clause, used to restrict rows returned based on search condition. You have also seen how search conditions can be written using comparison operators. The sales department is so impressed with your quick turnaround that they asked if you could help them find the order ID, customer ID, order dates of orders shipped prior to 1998 May 4th. You let them know it won't be a problem. However, you know you need to think about how to approach this requirement because unlike the requirement just completed, the filter condition is not going to be exactly compared to a value. The sales department wants shipped dates prior to a specific date, May 4th, 1998. You rightly figured out that for a date value to be prior to the one you are given, those dates must be less than the date value given. With that quick mental design, you are ready to whip out the query designer. Pay particular attention to step 5 that asks if you are filtering unwanted data. You are interested in dates prior to. which means yes, you will be filtering data out of the query result. So the answer there is yes. And the clause to filter data in SQL is the where clause. Then step 7 helps you build out the search condition, which in this case is the ship date less than May 4th, 1998. Your final query based on your design thus becomes: for the sales department's requirements, you see how we use yet another comparison operator, the less than operator, to build a search condition for the where clause to filter data prior to May 4th, 1998. You should also note that the column we use to filter our data, ship date, is not included in the select clause. This means we are not displaying the ship date in our query result as part of this requirement. You can include the ship date in your own select clause to visually inspect and verify that the data returned are indeed those shipped prior to the specified date. Finally, the literal date value, 1998 May 4th, is also bound in single quote. For now, as a rule of thumb, any non-numeric literal data value, that is the car, ncar, varchar, nvarchar, datetime, small datetime, and date, should be bound in single quote. Run the code and review the results. Before we leave comparison operators, we need to quickly discuss the concept of nulls. You got introduced to nulls when we discussed data types earlier on. We said the word null in programming is used when data is not known. At that point, we said anywhere you see the word null, you should think empty or not known. When using comparison operators, you should be careful not to think of nulls as zero or an empty string, because nulls do not equate to anything. As a matter of fact, one null is not equal to another null. Null just means we don't know. And because of this, we say in programming, null fails all equivalency. Nulls are, however, useful because we can set any data value to null whenever we do not have that data at the moment. For example, not all not winged orders have been shipped. If you look at the order table, you will find some rows without a date value in the ship date column. Instead of a date value, these rows have null, signifying that we do not have a ship date yet. Hence, those orders have not been shipped. If you are tasked with finding all the orders that have not yet been shipped, your query design may look something like what you see. Focus on step 6, where you derived your search criteria. Based on what you have learned about comparison operators and the where clause, you may have been tempted to write a where clause to find ship date that are null. Try running that query. You will see that no rows are returned, giving the impression that all orders have been shipped. The problem here is that you are comparing the ship date column, which should contain dates when orders are shipped, to null. Remember, we said earlier, null fails all equivalency. This means we cannot treat nulls the same way we do all other data values for this reason. We cannot compare nulls with anything. We need to treat nulls specially when we are comparing it with any other data value. In SQL, we use is null whenever we are comparing nulls with any data value. We can say that the comparison operator for nulls is null. Note that the operator is two words, is and null, not one word. Let us rewrite steps 6 and 7 in our query designer to implement this new syntax. Rerunning our query using the new design implementing the is null operator revealed that NotWin has 21 orders that has not been shipped. You will deal with nulls a lot, and they have been known to trip people up. Knowledge of things like knowing the correct operator to use when comparing nulls reduces frustration caused by nulls. To end this lesson, try your hands out on the following 3 exercises. Submit your responses either via Microsoft Teams or share your script with me through email to have them graded with my feedback. Remember, whenever you are tasked with writing a query, first, design the query using the query designer. Secondly, transfer your design to SSMS. And finally, execute your query and review the results, ensuring you are answering the question asked with your query. You may need to iterate between the query designer and SSMS as you tackle queries. That's fine. It's part of the learning process. In this lesson, we discussed the comparison operators, introduced the where clause that takes a predicate and helps filter rows returned from our queries. We then ended with a discussion on nulls. In the next lesson, we will be adding more tools into our query toolbox by discussing logical operators. Remember, as you continue to learn more querying techniques, attempting questions remains the only way to hone your new skills. So keep practicing questions both in the class videos and our project repository. Please like and subscribe to our class channel to make sure this reaches everyone seeking to learn database development skills and keep our channel relevant. See you shortly in the next class. Thank you.